All right, good morning, everyone. Thanks for coming. I'm Mark Abdulal from Cintel and presenting our concept for USEN, which is the UAS Swarm Electronic Kill Network. So, UAS technology is proliferated, and it's done so at a rate that, defied expectations. So, that has given our adversaries and asymmetric adversaries a capability that leaves us vulnerable. They can do A2AD, ISR, and even deploy combat missions. So, furthermore, our responses to these threats can also leave us more vulnerable. As many of you may have heard, one of our allies performed an intercept with a Patriot on a $200 UAS. And while that intercept was successful, the engagement was not, right? So, what we're presenting is a solution to mitigate that threat by leveraging UAS swarm architecture and a jamming and spoofing capability to perform a soft kill on those UAS or adversary UAS. Can everybody hear me okay? Okay. So just as UAS technologies increased and proliferated and miniaturized and excelled, so is jamming and spoofing. You can go online and buy a jammer relatively inexpensively. The one I show up here, it's difficult to see. It jams up to 20 meters. It weighs about a pound. And just about anybody can get their hands on these. And so there's a customer review, which I have on here, which you may not be able to see, but it's pretty funny. But an author, Brandon, said, "I did some testing, and this thing just destroys signals like I've never seen before." So, to speak to its potency, within that 20 meters, you can zap through it and kind of jam through RF signals. Spoofing, on the other hand, isn't as prolific. It's kind of not as mature. However, there have been notable cases. So UT Austin did a study where they spoofed a UAS and a yacht and were able to kind of hijack them. The Pokemon Go, people were able to actually hijack their own phones and spoof their phones into reporting areas where they actually weren't in order to game the game. And then in January, there were some reports of drug cartels in Mexico spoofing Predator drones that were employed by Border Patrol. So it is a possibility, however, there aren't any COTS solutions for that currently. So one of the things with employing jamming and spoofing on your own UAS is that you'll inevitably jam and spoof yourself. So positioning, navigation, and timing is now a concern. So one of the things that we are employing or supposing that will be of benefit to this concept is a relative positioning concept. So if you take classical mechanics, you have the degrees of freedom. So it's just basically the configurations that bodies can occupy in space. And one of the ways we can reduce that dimensionality is through constraint equations. And those are, think of them as rule sets that govern the motion of bodies. So we already see these principles in place. So to deconflict airspace, if two aircraft are on a collision course, they're both supposed to turn right. So within a bubble, you can identify the configuration that those two bodies are going to be in. One of the first things I learned in Marine Corps basic training was close order drill. And essentially, you have, depending on what squad you're in, you'll learn different rule sets on how far away to be away from the person in front of you and from to the right and the left. So there's going to be many more rule sets in a system like that. And what you end up getting is a rigid swarm that is very controllable. So, so you have two kind of opposite sides of the coin where where you have limited rule sets allow kind of much autonomy, and then the other side of the spectrum is where you have a very limited availability to kind of be agile. We've employed a limited rule set with autonomous agents, and what we're able to show is that you can kind of get them to follow around based on a limited amount of rule sets and maintain a swarm actual bubble. So. And furthermore, once you have these degrees of freedom, and this is infinitely scalable, right? So you can have as many UAS and as many rules. There isn't an upper limit to how many you can employ. So that's our local positioning. Where am I with respect to my neighbor? There's another task of doing an absolute determination of where you are with respect to your environment. And we're leveraging GIS in this circumstance. So we're taking the video, we'll take the video feeds from the UAS and do pattern recognition, run neural net to identify where you are within your downloaded GIS picture. That'll help determine where you currently are, and you can determine things like heading and speed and things of that nature based on the downloaded data set that you already have, that you load up prior to mission. I'd also like to say that we're currently working parts of this right now. We have a phase 1 SBIR to do cooperative engagement, guidance, navigation, and control. So elements of this will be solved in that SBIR. So one of the things that we need to consider in taking a concept to reality is the sensitivity of different elements of our performance and design. So one of the biggest things is how many UAS, how big of this is this network, right? And then essentially, how big is the jamming radius? On one end of the spectrum, you can use one UAS that's maximally powerful and has a huge kill radius. On the other end, you can have very small radius and employ many small UAS. And there is going to be a trade-off associated with those. So to take this concept into design, we'll need to assess just that. What do the numbers look like? What is the performance of currently available COT systems that can do the things we need to get done? So essentially, we need to do a feasibility study that's going to draw heavily on modeling and simulation. So we'll be needing to do the cyber, electromechanical, conceptual design, and modeling and simulation associated with those. Furthermore, we need to identify what UAS platforms can do the job that we need. I think essentially early on we're finding that very small UAS can't carry much of a payload that would require spoofers and jammers and things of that nature. So kind of bumps us up to the upper regions. And finally, we seek to do prototype development too for the spoofing capability. We've identified GPS simulators and antennas, and that solution exists obviously, but there isn't a COT solution that could be available to the government. So we seek to develop that prototype, as well as integrate an existing UAS or a new UAS with the EW subsystems. So we think we're particularly well suited for this job because Cintel, we're at the center of an active ecosystem. We leverage our relationships with research labs and academia to take research and applied research and turn that into technology. And using our innovations, we're able to kind of leverage that to create those technologies. And by teaming with the big OEMs and partnering with them, we can take those technologies and turn them into products that are resistant to things like arbitrary and parts mismatches and obsolescence specifically. So I'd like to open it up to any questions. I appreciate the time. Thank you very much. Yes, sir.
I was wondering if you were going to leverage big data and pulling things through a cloud, a private cloud or a public cloud, in order to analyze it and send it back down, or are you on board going to do all of the...
No, that's a good question. So the question was to whether or not we're going to leverage big data, and I think that'll be potentially a fringe kind of exploration because we're trying to kind of limit how much communications we're doing online because we're blasting everything away. So it's going to be difficult to send communications within the UAS. So we're heavily leveraging the visual feeds that you're going to have on the cameras to be able to do the positioning and absolute positioning. So yeah, that's all the time I have. Thank you so much.